And today, first of all, I want to tell you about clean code. I hope you remember then that clean code, it's a code that's easy to read and easy to change. And it's easy to fix bugs and add new features. Today we will talk about three main things about formatting. This is about how your code looks. Good formatting makes your code easier to understand. About error processing, this means how your code deals with problems like a wrong input or a failed connection. And about solid principles and other principles of object-oriented programming. These are simple rules to help you write better code. They help your code stay clean, flexible, and easy to work. And even if you select functional programming, I think these principles can help you too. Let's start with the first topic, formatting. Let's talk about how to organize your code in files. This helps your project stay clean and easy to understand. Here are three simple rules. First of all, put each class in a separate files. This means if you have a class called, for example, user, put it in a file called user.java or user.python, or it depends from what language do you use. This makes it easier to find the class when you need to change or read it. The second, name the file after the class. The file name should match the class name. For example, if you have the class order, it means that it should be inside the file order.java or something else. This is a common rule in many programming languages and helps keep things clear. And the third one, use empty lines or comments to show where one method ends and the next one starts. This makes it easier for other developers or maybe for you in the future to read your code. Good file organization makes teamwork and debugging much easier. Let's look example. Here we have the
Excuse
code.
me, teacher.
Yes.
The I was taking the screenshots, but there is one question. We have to write an answer in that. The answer won't come there if I take a screenshot.
I will
So what should I
create
do?
the task in Google Classroom and you will send the screenshots and the text answers, okay?
Yeah, okay, I got it. But the text answer also I will put as a text. Okay.
Mm-hmm.
Okay, sure. Thank you. I will take a screenshot.
Mm-hmm. So in this slide, we can see the example of code with bad formatting. I think that it's very hard to understand this code because there are no line breaks, no spaces or another things. Even though the code works, it's very hard to read. It's difficult to see where loops begin and end or what each part does. Imagine trying to debug this code. I think it's will be very hard. That's why we need to add some formatting. And this is the same code but with formatting. This version is much easier to read. We see clear indentation that show the structure. For example, where the for loop and while loop start and end. Spaces around the lines of code, spaces around the operators like equal or more, which improve readability. Empty lines between logical sections in the code, and line breaks that keep lines short and clear. Good formatting helps you understand what the code is doing, even before reading every line in detail. Also, it will help your teammates and your future to understand this code. So, this is a key idea in clean code. When your code is well formatted, we can see the logic and we understand everything step by step, block by block. Uh, good formatting is code good formatting code is something like layout in a website. Usually when you open the website, you know in which block you can see some information. First of all, in the top of the website you can see the logo, the title, and another the most important part you will see in the center. The same rules works for our code. That's why it's so important, and if we will use some structure in our code, it will be easier to understand it. It's something like communication with your format of code. You try to communicate with another developers. In most programming languages, we read code from top to bottom, like a book. So how we place things vertically really matters. Here are some simple rules. First of all, follow your language's style guide. Each language has typical formatting rules. That's why it's necessary to learn them and follow them. The second, separate code blocks with blank lines. I already told you about it, because space between groups of codes make easier to read them. Keep related lines together. If two lines of code belong to the same idea, they should be close to each other. And if you create some variables, place these variables near their usage, because it will be simple to understand it, to read it, and is not necessary to scroll the code. When two methods depend on each other, put them side by side. Depend from each other means that, for example, in first method we run the second method. Because when you read the code, you see how they work together. You don't need to scroll up or and down to understand the logic. Also, two code blocks do similar things, like processing data or maybe checking conditions. Keep them close. This helps your brain group them as one idea and understand fastly. It's like organizing in your home, for example. Related things should be near each other. This makes the code easier to follow and reduces mental effort. It's very important because our work not so easy. When you write a class, the order of elements matters. Consistent and clean structure helps us to read and understand. There is a good order to follow. If you use such languages as C++ and you have a special file for interface and special file for implementation, you can use these rules, this structure. At the top of the class, if we tell about interface, in the top of the class, write a short comment that explain what this class does. Of course, only if your class is complex. If you have little simple class, like some data class, for example, isn't necessary to add comments because I think it's easy to understand what this class does. Then constructors and destructors. These come first in the body of the class because they show how the class is created and destroyed. Not class, but objects of this class. Then public methods. They are used by other parts of the program. That's why it's necessary to put them near the top after the constructors, because we need them very often. After that, protected methods. These are only used by this class or its children. That's why we don't need them so often. And the next is private methods and data, because they are only for internal use. If you create class implementation, not interface, the order is the same. but here we have the fields, and it's better to use the fields after class description, but before constructors and destructors. Of course, we should have getters and setters for our fields. Then, when we talk about the formatting, we should think not only about vertical but about horizontal formatting. And line length matters. If lines are too long, it's very hard to read them, and we need to scroll horizontally. Or, for example, I have the mouse for Apple developers, and here I have special gesture to scroll the content horizontally. But usually, mouse can't do it. That's why it's very hard to scroll it. We need to do some not interesting things. That's why it's better to use short lines. For example, Robert Martin, it's an author of Clean Architecture and Clean Code book, thinks and recommends to use no more than 120 symbols. When you use some IDE like Android Studio, IntelliJ IDEA, Visual Studio, or another, you can see the line in the end of your screen, and it's some kind of constraint. And this line equals to 120 symbols. So it's better to create your lines of code less than 120 characters per line. That's a good balance because it fits on most screens. It's long enough for complex logic. It keeps your code clean and readable. Also, avoid putting too much logic in one line because it's hard to read. And break the line into smaller parts if you need very long. Another rule, look at this expression. I think that most developers think they know what it does, but many of us don't actually remember the exact order of operations. What we should do the first, divide or multiply, and another rows. That's why it's better to use brackets in such operations. And add spaces around operators because this improves readability, just like punctuation in sentences. And use some hotkeys like Ctrl Shift L, for example, because it's a shortcut which can make auto format in your code and make it more readable and beautiful automatically. It's very simple. If you don't know the shortcut for you IDE, I recommended you to check it to find in Google or maybe in documentation for your instrument and use it very often. The next topic, it's about handle errors in code because it's important too. First of all, the little code, only he who does nothing is not mistaken. We works with people. We can find not only bugs, but we can find some problems in code, and that's okay. What matters is how we handle these problems, like incorrect format of data or something else. In programming, we have two main ways to deal with errors. First of all, it's error codes, and the second, it's exception. And in books about refactoring and clean code, the authors recommended us to use exceptions instead of error codes. Because error codes are easy to forget to check, they can be unclear. For example, you work with error codes when you create some connection between client and server. For example, you create the request to the server and you get the 404 error code. And what is it? Maybe we forgot what is it. Maybe we don't know what this code means. That's why it's not so good idea to work with error codes. The exceptions are better. Uh, Exceptions allows us to separate normal logic from error logic. They're easier to manage, more readable, and safer. And we can use try and catch and handle problems very clearly. Then, in real life, we lock our doors to stay safe. In code, we must do the same. Your program should never trust external data from external sources. For example, user input can have the errors, some files from memory of our device, responses from API, data from internet, anything that comes from outside of your code can contain the errors, the problems. And it can be dangerous. That's why always check and maybe clean the data before using it. Check the type, check the range, check the format. It's better to check everything, and usually we code it input validation. That's why it's better to validate everything, because it protects your program from crashes, bugs, and security risks. Another not problem but rule. uh, when someone calls your method, they might pass in bad values, and it may be the reason of some problems or crashes. That's why always check the values of all input parameters. If you create some function or method, please always check all input parameters, because it can be null or maybe empty or too short or too long, or it can have unexpected format. That's why always check them. Because if you don't check inputs, bugs will appear later in some strange places, and that makes debugging harder. There are many ways to handling errors in code, and each one is useful in different situations. Here in this slide, you can see the list of solutions, and let's go through the most common methods. First of all, return the natural value. For example, you can return something like 0 or maybe empty list, and you can use this method in some applications like calculator. If user enters invalid input, you can just return 0, and this avoids crashes and keep the flow going. The second method is replace with the next valid data block. If the current block of data is broken, we can just skip it and use the next one. For example, if you create video player and current frame is corrupted, you can show the next frame, and maybe user may not even notice the problem. The next method, return the same result as before. If real-time data fails, we can just repeat the last good value. For example, you create the weather application, and if new data fails, we can show the last known forecast. And user will get some information, because weather changes not so fast. The next, substitute the nearest valid value. For example, if current value is too high, we can use the maximum allowed. Like in some temperature control system, if user sets 150 50, yes, but maximum is 120, we can send just 120 because it's a allowed maximum, and this keeps the system within safe limits. The next method, write warning message to file. um, I think that we should do it in every case when we have some problems, because we create the log file, we create the history, and it allows us to check this situation in the future, and maybe change something to avoid the repeating of this situation. For example, in a server application, if some file is missing, we can log this information, the warning about it, and developers will fix this issue later. The next method is return the error code. If we don't know what to do with this problem, we can just return the error code and push the problem to the next level of the system. Another developers should work with this problem, because now we just have not any information what we can do with it. For example, if you create the library and something happened, you can just return some value like -1 or exception or signal, and someone who called this function will decide what to do with this problem. It's a flexible method but requires careful handling. Another method, it's call the method of the error handler object. In some system we have special object which works with all problems, like global error handler, and we can create this error handler and use and call it when we have some problems. It allows us to create centralized and consistent system to solve all problems. The next, it's show error message, and we can use it when we create some user interface, some client application, and we just let the user know what happened. For example, in a form on a website, we can just show email is invalid in input format, and helps the user fix the mistake directly. User will just change the input and use correct email. And the next, it's a stop execution. In some crucial and critical situations, we just need to crash fast and clearly. For example, when we create the banking app, if we have some problem, we need to stop immediately, because if we did not do if we will not do anything, we can fail a lot of money or security data of our users. I think we can't do it. That's why it's better to crash the application, and that's all. And of course, create the warning message in a log file to help another developers check it and find the reason of the problem. The next recommendation, when we work with exceptions, we here in this slide I have the little example, and this method get tax ID is part of some employee class. It's a business logic of some application, but it returns us a technical exception and a file exception. That's a low level input output error, and it breaks the abstraction. The person who use employee class, the developer who use it, should not have to know about file streams. This developer works with business logic. he or she does not know everything about end of file, about how we store this information. He or she just need to get some information about employee in the level of business logic. That's why instead we can return high level, more meaningful exception, like in this slide. Here we can store some information about, we just call it employee data not available, but inside this exception we can store the information while why it does it happened. Another recommendation, enter all information about the reasons for the exception description. And here I have two examples. First examples, it's a bad code because it does not contain any information. What runtime exception? How does it happen? So how we can change the situation. But the second, it's a correct because here we have description. User ID must be positive, and we have the bad variant which we have now. That's why when you create your own exception, it's better to add all information. And another recommendation about how to work with problems in your code, I think it's most important because every students do it every time. When you create try-catch blocks, you forget to work with catch part. When you catch exception, you need to do something. Never write this in this style with empty catch block because it's dangerous. You're hiding the error. The problem may continue in a broken state. Debugging becomes a nightmare because no logs, no info, no something. Instead, always handle the error property. You can log it, you can show message, you can retry operation, you can use some of these items. Please do something when you create the catch block, because if you catch it, respect it. And empty catch blocks equals to silent bugs, and you will have a lot of problems in the future. That's all about error handling. And the next slide is about the second part of today's lesson. That's why I suggest to have a short rest. I will create for you the task in a Google Classroom for those students who have the screenshots of their answers to
Okay, okay, teachers.
Comment like just this just works don't sometimes it's correct comments, because sometimes we can have very strange code in our programs. It's some kind of cheating, or maybe trying to solve the problems of frameworks or something else. And another developers, when see at this code, will not understand why this code is so strange. That's why this type of comment that this code works, please don't touch it. Sometimes we can use it just to explain another developers that it looks strange, yes, but it's correct. And I think that you will not find a better solution of this problem. That's why in this situation, when you try to mark the code which were strange because of some problems in framework or some unusual scenarios in your application, you can use this comment. So I stop the record.